All right, so I think this is recording. Let's take a look here at this problem. They want us to multiply these two rational expressions together to get a single rational expression written in lowest terms, but to also state any restrictions that we have. Restrictions come from the fact that we have variables in a denominator, and we have to make sure that the denominator is never equal to 0 because that would cause division by 0, and that's undefined. All right, so I'm going to start out by writing these two fractions as a single fraction. So all I'm going to do is put parentheses around each binomial. And the same idea in the denominator. Now I have a word of caution. We immediately see that we have two factors that could cancel, that this factor cancels with this factor. But right now, it's difficult. I haven't stated my restrictions yet, and unless I factor this binomial, completely factor that binomial, it's going to be hard for me to see all of my restrictions. So I'm going to hold off on canceling those two factors right now. I'm going to go off to the side and begin with these binomials and rewriting these binomials in factored form. So I'm going to look at 9r cubed as 9r squared times r. And I'm going to look at 54r squared as 9r squared times 6. And I can see that I have a 9r squared that's common to both terms. And the same idea with this second binomial. I've got 9r squared, and I'm going to write that as 9r times r plus 9r times 1. And I see that 9r is common to both terms. If I look at my denominator, I've got 9r squared plus 45r. I'm going to write it as 9r times r, and the 45r as 9r times 5. And you can see that 9r is common. All right, so let's come back. In our numerator, this 9r cubed minus 54r squared, we factored it to 9r squared times r minus 6. This the second factor here, we factored it to 9r times r plus 1. In the denominator, this 9r squared plus 45r, we factored it to 9r times r plus 5. And this factor was the same as this factor, so it factors to 9r squared times r minus 6. Now, everything's in completely factored form, and it's a lot easier to see what my restrictions are, and it's going to be easy to cancel common factors. So since we have a single factor of r right there, if that r were to equal 0, and since you have multiplication, that whole denominator would be 0, we need to prevent that from happening. So r can't be 0. If r was negative 5 plus 5 would give me 0, and I can't allow that to happen. I've already taken care of 0 over in this factor, so I don't have to write it again. And 6 minus 6 would give me a 0. Need to prevent that from happening. All right, so let's come in and see what can cancel. I have an r minus 6 divided by an r minus 6. I have a 9r divided by 9r. I have a 9r squared divided by 9r squared. And that looks like all the factors that are common. So in the numerator, what I have left is r plus 1. And in the denominator, what I have left is r plus 5. course, it would never reduce if r were allowed to equal any of these values. So here's our restrictions. And that's our final answer. All right, well, I hope that helps. Take something complicated and break it down. The whole key on this stuff is factoring. All right. Talk to you later. Bye.